So if you look at the definition of metabolism, all of us would think, oh, that's just how fast your body burns calories. That's your metabolism. But it's really the total of chemical reactions happening in every cell. And so on a huge level, that's where you get calories. But, you're looking at quantities so small. That's why it's actually called a kilocalorie. You're looking at the amount of energy needed to fuel a cell, or the amount of energy actually generated in a cell. So the sum total of all of that is what you and I would consider your metabolism as you're discussing that with clients. So I do want to touch on some of that stuff, even though that's not in the book. It's more in the workbook, talking about metabolic capacity, metabolic change. But let's dive into at least some of the elements in that second section, which is how our body breaks down nutrients for energy. And feel free to jump in anytime on this.
No, that's all you.
Tyler.
That's all you. You're the man. You're the man with it.
I didn't want to just roll
No,
this and leave you out.
You're doing good.
All right. We will get to some more practical stuff.
Yeah, no.
But so we have carbs, fat, and protein. Those are the macronutrients, and those are broken down into different constituents. So you've heard of the terms ATP, adenosine triphosphate. That's kind of the end result of the breakdown of anything that your body's going to use for energy. So carbohydrates are broken down into glucose for usable energy, but that glucose then goes into a process by which we end up with things like pyruvate, acetyl-CoA, ATP, and that's that whole Krebs cycle. So that's the entire breakdown of energy. And you can do that with fat. Fats are broken down into glycerol and fatty acids to be used. Interestingly, there's where there is a division, because fatty acids can't be used for pyruvate. They are what gets turned into acetyl-CoA, which can then become ketone bodies. And that, of course, when we run out of glucose, our body's forced to use fats directly. And since you can't really use fats like a triglyceride directly, that has to be broken down into those smaller components, which again are the acetyl-CoA and ketone bodies. Even your brain, this is right out of the text, you guys. This is the kind of stuff I want you to learn from the text. Your brain uses glucose as energy. All of your cells use glucose as energy. But when those aren't available, then we take those fatty acids and break them down through that different component. So you end up, if you look at the TCA cycle, electron transport, the different ways as you kind of follow those chains down into how we derive those energy sources, that's really what I want you to know for this, is just have a cursory understanding of how that gets broken down. Because like I said, even protein is broken down into amino acids, and that can be taken into that same pathway, and that's why catabolism is possible. That's how you can lose, muscle tissue, or at least the amino acids from the muscle tissue. So let's move on to some better stuff.
Sure.
So the third section,
I love listening.
All right, the third section in this stuff is actually it's kind of interesting.
Yeah.
When you see it on paper and you see those graphics, but at the same time, it's like, I learned that and forgot it for a reason, because you never use it, right? But the third section in this chapter that is at least in the syllabus is feasting and fasting, which just means being overfed or being in a diet state, even to the point of starvation. So this is where it gets a little bit more real in terms of what you're going to experience as coaches and clinicians. Like I said, you're never going to explain any of that stuff in section 1 and 2 to clients. It's just for you to understand a little bit of the background of where this stuff comes from. Because, again, even though the NAM's mission is to create coaches, we want you to be informed coaches, educated coaches. We want you to at least have that background that is a step above everybody else. So you can throw some of these terms around at functions, and you'll just look so smart.
Yes.
But let's get into the feasting and fasting. So what happens? We talked a lot about this a couple of videos ago in a section we described as metabolic positioning. But if you over-consume carbohydrates, this is where Tyler's going to jump in. I'm going to talk about over-consuming carbs, over-consuming fat, and over-consuming protein. Okay. So assuming just in one particular meal. somebody has, you were just talking about over-consuming protein. We might start there. A little childhood memory.
Yeah.
Tyler
Interesting.
over-consumed an entire box of beef jerky.
Yeah, I threw up for hours after. It felt great.
So if you over-consume, well, let's back up to carbs. We'll kind of take it in order. If you over-consume carbs in one meal, what happens?
Well, glycogen gets refilled. You create body fat, depending on the body type and who's overeating and how much, depending on the quantity. But glycogen gets filled up first, then excess gets stored into body fat.
Mm-hmm. Yes, and it's always interesting to me because this is stuff I learned 25, 30 years ago. I love when I pick up a textbook and see that those core parts of nutrition just have not changed. They're not described any differently because we do get down to some base truths that are just final. They're foundational. And so it's described in the text exactly as I learned it that long ago. And quite literally, excess carbohydrates that you cannot digest and assimilate at one time get stored as glycogen. But at the very same time that conversion is happening, excess glucose can be converted to body fat at least two ways. So this is important to know. I used to teach in lectures, there was kind of a magic number. Like you hit about 25, 30 grams of carbs, and that's where insulin is triggered, and you immediately go into a fat storage mode. But contextually, we know if you've just trained extremely hard or you're in the middle of training, your body might churn through a lot more. If you have a high metabolism in general, I've had clients eat 1,000 grams of carbs a day.
Yeah, how do you know when the fine line is whether it's actually starting to store or drink more insulin?
Well, that's, if you're not just hooked up to a blood monitor to test it around the clock, it's just literally as the scientific method describes. It's observation, and then you have the question, and then you say, if I plug this into, my data sets, like I'm just meaning, I didn't mean to get that complex, but meaning, did I gain weight this week? Did I lose weight this week? Do I feel tighter? Am I
so the real
seeing
strict monitoring, just really paying attention
Absolutely.
to being objective with yourself.
Absolutely. But so I did want to explain this one thing because I don't know if the book quite described it like this. Let's say you overconsume carbs for what your body needs. And to Tyler's point, there is no magic number that you can just say, here's what you can't go over. But based on your client's genetics, your client's daily situation where they're in that context of their day, let's say that they consume more carbs than they need. A small overage, even a moderate overage, is not as bad as we used to think. I used to teach that instantly, you start going in that storage mode, and excess carbs can be converted to body fat. Excess glucose in the bloodstream can be pulled into fat cells and just directly converted into body fat. It can go through your liver and be converted to body fat as a cholesterol and then stored. That is absolutely a mechanism of over-consuming carbs. But the way I learned it and taught it for years doesn't seem to be quite as alarmist as new research. I looked at two studies. One showed that if you over-consumed carbs by 500 grams a day,
Wow. Okay.
so that's a lot.
That's a lot.
For 21 days straight, you're
You're
definitely
definitely gonna put on some fat.
Yeah, you would think, like, I personally think I would probably gain 15 pounds of body fat.
Yeah.
But they showed only 6% of that excess energy ended up stored as fat.
Interesting. So it's in excess of what you already eat.
Of what you already need.
Okay.
So your basal metabolic
So
rate.
if you need 150 grams of carbs a day, roughly, as your basal,
You still ate 500 more.
so you're eating 650.
Right.
Wow.
And there was a diversity of genetics, so they didn't say only people that have a metabolic rate of 150 grams of carbs a day. But it was fascinating to see that so little of it got converted to fat.
Wow.
And I think it's because there's such an acute rise in metabolism with that. So it goes to show that we've always had things like higher carb days or higher calorie days that we allow for social reasons, for metabolic reasons. It's in the, at least not the literature, but it's being proposed by people that maybe you need more than 1 day a week. You need like 2 back-to-back days because you're just it's almost kind of a metabolic tease to get a little bit of carbs, but you really need to kind of saturate your glycogen levels a little bit, and then that supports your metabolism better. So maybe 2 days in a row of higher calories per week.
Okay.
Now that could be helpful.
Were they coming from like a depleted state, or were they coming from just normal?
I thought it was just normal. Yeah,
Okay.
just pretty normal stuff.
Interesting.
But here's the thing. I don't know if I can trust those couple of new studies entirely, because like I said, if I ate 500 grams of carbs a day, clean carbs, like not fat, for 21 days, I have a feeling I would be storing some body fat.
Well, mentally, it would just make people go crazy, because they would just, if they gain weight, they think that it's bad. And so that initial thought of weight gain, even though it's just probably glycogen and water.
Yeah, and so the thing I wanted to emphasize with this point is we talked about research, we talked about how to consume research, and as I said, there is a set base of information that's relied upon. It's been peer-reviewed, it's been published, it's been combed through by editors for textbooks, and here's something new that's being proposed, and I think it's interesting, but I don't know if it's going to hold water for the long term. Hold water, glycogen. Play on words.
No pun intended.
But here's what I do want you to know for this. When you are breaking down carbohydrates into glucose, and then your body is breaking that down into ATP and other things, there is a reversal to that, where excess glucose then gets stored as glycogen. Excess, even after your glycogen has been kind of filled or saturated, you end up converting that to body fat. And even with this little controversy I mentioned, it will end up turning into body fats. I mean, that is the end result. But here's the thing that I think people miss, and this is the intention of those studies. It's really the dietary fat in your body that gets stored as fat most easily. So if you have a meal that has a lot of carbohydrate and a lot of fat, your body's going to use those carbs first. You're going to use some of those carbs to refill glycogen levels that may, be available, space available. But while all that's happening, the dietary fat that you've also consumed with those carbs, that immediately gets stored as fat.
So that's the calories on that is much, much higher too. And when you have a plate of pasta that's full of Alfredo sauce, you might just be thinking of just the carbs, but really you're eating 40 or 50 grams of fat on top of it.
Right. And that truly is a difference. So, let's say you only ate the Alfredo sauce, and so you're kind of keto, I'm just going to have all this fat. Well, some of that will get used as energy because you need it, you've got no carbs, but a large majority gets stored as fat initially.